Hey guys, before we get started, I want to make a couple of comments about this unit. You know, a lot of us that watch, people who watch my channel watch the same kind of things I do, and they're, about old, tube radios, tube televisions, and, you're accustomed to seeing instances of hundreds of volts, if not thousands of volts, particularly on televisions. But, we can become complacent in terms of thinking that that is usually within the cabinet or within the case. In this case, or this unit, there is actually a wire that hangs outside of the cabinet of this, that if you were to put power to this unit, it'll generate 1,000 volts out at the end of a wire that's just hanging out there. You might not suspect something like that was possible, so I want to give you a heads up on that. So I would encourage you to not try to do anything I'm doing here. If you have one of these, be aware. You may want to take this to a serviceman. If you're not one yourself who's familiar with this kind of equipment and this kind of voltages, and make this safe for your purposes, or not use it at all if you like. But I would encourage you, just take a look at my video. Don't attempt to do anything I'm doing here. Just enjoy looking at some history, and thanks. Hey guys, so welcome back. Well, what we have laid out in front of you is a new old stock Autronic-Eye for a 1953 Chevrolet. This belongs to a guy that has a 53 Chevy, a Deluxe 210, 4-door. And as you can see, this thing is new old stock. I'm going to show you all the pieces in turn, and then I'm going to explain a little bit about how it operates, and then we'll see where we go from there. Basically, this is the part that would be inside the car and on top of your dash. You'd mount this on top of your dash over to the left. So you have your steering wheel, right? You'd have this over here to the left. And what it does is it looks out through the windshield and it picks up light from oncoming cars. So what this does is this automatically dims your headlights when a car is detected coming at you, and then when the car goes away, it then turns your brights back on. So it automatically flips between bright and low beam, or high and low beam. And if you haven't seen one of these new old stock, I thought we'd take a look at it and just look at the beauty of this thing. Got an airplane. I don't know if I mentioned it or not, but I had never laid eyes on one of these before this arrived. You can see the way it's mounted here. It's got a mounting screw and a post here for holding in a particular orientation. And there's a hole here for sensitivity adjustment. Alright, let's look at some of the other items that are here. So the eye talks to a couple of items. This is the amplifier unit. So this connects to the battery, and it has a transformer in here, and it provides the necessary voltage for operating the eye and the amplifier unit. Now, this is from 1953. There aren't any transistors, right? So this is all vacuum tube. And the amplifier in here will generate, I think it's about 120 volts from a 6-volt car battery, by the way, and will operate the tubes that are in here. But then what's really interesting is that this has a photomultiplier tube in it, and the voltage that goes to this is, hold on to your hat, 1,000 volts. So can you imagine when you have this in your car, you've got a 1,000 volt connection that runs from this amplifier unit, which is mounted under the hood through the firewall, and then mounted to this unit, which is on the top of your dash over to the left. So this provides the amplification for that, and then it then detects the signal from the photomultiplier that it sees another car's headlights coming, and then it sends a signal to this relay. And this relay is what trips the lights from being high beam and low beam. Let me get a close-up of this. So as you can see, this has never been installed. This is, what is that, 69 years? This is the end of 2022, so this is for 53. And this just says UB, I don't know if you can see that or not, UB and LB, upper, I guess upper beam and lower beam. Okay. Then the thing is turned on and off by the pedals. So, you know, guys my age remember this, but the high beams and low beams on cars are operated by your foot over against the left side of the floorboard, underneath the brake pedal usually. And there's a button there that you push, and it was a click on, click. It was basically a toggle button. It was click to high beams, then click again to turn the high beams off. Okay, and so they provide you one of those here, and this is exactly what they look like. This is your foot pedal switch. That's what you hit with your foot. And what this does, though, when it's mounted in the Autronic-Eye setup, is it basically enables the system to be on and automatic. So normally, if you have the switch to basically, let's say, low beam, then your low beam lights are on. But then when you want high beams, you then click this again, and that goes into what's called the automatic mode for the Autronic-Eye. And then the eye controls whether the high beams or the low beams are on. Okay. Now let's say you're driving along and a headlight comes on and the lights are very bright, and your light's dim, but the other guy leaves his lights on bright, and you want to like flash him and say, hey man, turn your brights off, or maybe there's some other reason you want to signal to a car. So there is another button that you mount on the floorboard that's the auxiliary foot switch. So this is another one, and this is used so that you can momentarily turn on your brights. So it's like an override for this. So when this, because an oncoming car, turns the brights down to low, this allows you to push on the button and override that and put your highs back on. Okay, and then you release that, then this goes back to low, I guess because this is detecting a car, and when the car passes, then the amplifier unit doesn't see the signal anymore, drops out, and then the relay kicks it back up to high beams. That's the way this works. The fellow that sent this to me, he asked me, you know, just take a look at it, see if it works, and see if it needs any attention. Well, it's got some capacitors in here that I'm pretty sure are going to be pretty much not really worth using right now. And there's an area in the voltage that's going to see high voltage. So let me show that to you. Now, some of the things he sent me, I've got a binder of documents here, because he also sent me some documents for some radios I've been working on for him as well. You may remember some of these. So in here he sent me a copy of the service manual for the Autronic-Eye, and there's also another manual in here. That's the repair manual for the Autronic-Eye, and then I'll get into that in a minute, but then some other amazing stuff that he sent me. So in here are the templates that you use to cut the dash to mount this. So these would be installed by dealers. So here we have the inspection tag for the set. Here is the template for setting this up inside your dash and drilling the holes for the cords, the screw hole, and for the pin, this orientation pin. Line up this edge with crease line in the instrument panel. Pretty cool. These are photocopies I believe he made and sent to me so I could see them. He's got the originals. Here's the tag that you would have, and the dealer would tie this with a string to the headlight switch in the car, so that when you got this you could see how to operate that. I'm going to zoom in here so you can see it, and pause and read it on your own if you want to. And when I look in this and edit, if this isn't clear, then I'll put another copy of it in here so you can read it. Oops, wind. Okay. Here's the template for putting the auxiliary foot switch in. How to drill the holes relative to the existing holes that are there for your foot switch. And then this is the instructions for installing it. Hope you can see that. I'm doing my best. So you can see here how you would mount this. Let him go by. Nice resonators. Okay, so here you can see how the unit is installed in your dash. There's your dash right here. You can see the unit passing through the window. Here you can see it installed in the inside of your dash. Here's where the foot pedals go next to your brake pedal, or I guess that would be clutch. And then here's another view showing how that's installed in the car. So in this manual I have, let's take a look at the schematic of this real quick. Okay, so here is the circuit for the photomultiplier tube, and if you know how they work, and I'll go into it a little more detail later, but basically you've got these elements of the tube that operate at different voltages, so you can see the network of resistors that are around here to assign them all a stage down set of voltages from where they start off. Where they start off is, let's go over here, and you'll see right here that says, I don't know if you can see that or not, 1150 volts AC. Okay, so by the time it goes through the rectifier, I believe it steps down to about 1000 volts DC. And then here's 120 volts that goes to the amplifier tube. We can see the rest of this here on the chart. I'll describe this a little bit later as we go. But the main elements of this we want to do is, I think what we want to do is check the condition of this capacitor right here. This capacitor is partly there to save the points in this element here. If you're not familiar with that, I'll describe it in a minute. And there's a few other capacitors in here. There's a 0.1, there's a 0.05, I think that's an 8 microfarad, and I need to check those out. There's no capacitors over here. This is in the dash unit, right? That's what this is. This is the cabling. It's got 1000 volts going through it here. And so I think what I want to do is, let me just describe for you a little bit quickly how this works, okay? So here is where this attaches to the wiring of the car. All right. So here the wiring comes in. This is your hot lead from your battery. Once again, this is a 6-volt system. And then these other two leads are for your upper beams and your lower beams. And they go off into the circuitry of the car. Okay. This is the relay right here, which is this fella. So what it does is operates the high beams and the low beams based on what this is telling it to do. If you press the auxiliary foot switch, this guy, then basically what it does is it does an override and kicks this in to where it'll go to back to high beams. So what it does is it puts current to this little relay coil in here, and when it does, it pulls it down to low beam. When it releases, it goes back to high beam. Okay, so let's talk about the voltage real quick. I'm not going to get into the detail of all of this. Let me just talk about the power supply. So the 6 volts comes in through here, okay, and actually through here. There's our fuse. You can see this. And then the voltage for the power supply comes up this way, and there's a dot there, so it's connected. And it comes over here, so we have 6 volts DC going into the ballast tube. Now the ballast tube is basically a power resistor for dropping the voltage. And depending on the current of the system, you have to make an adjustment. So you adjust it to where this one goes to 4 volts out of the ballast tube. Okay, then that voltage comes up and goes to the primary winding of this transformer. When it does that, it puts the 4 volts here. Now, you may be wondering, how in the world do you go from 4 volts DC to 1150 volts AC? I mean, did we just invent a perpetual motion machine? This is really, really clever, especially looking back on it. We take so many things for granted with the way we can handle power these days. Now, in order to get this voltage up high enough to operate these tubes, you have to have a transformer to step up to these voltages. Here and here, well, here and here. And the way they do it is they use a transformer. Now remember, a transformer needs to have alternating current in order for the transformer to work. If you just put DC in here, it just charges the magnetic field up and nothing happens. You got to have it alternating for the transformer to do any good. So how do we get alternating current out of a battery that's providing 4 volts by the time we get through the ballast tube? So what you do is you put that into the center tap of this primary. And then what you do is that then there's a bit of that voltage comes over into here and operates a coil inside of this element right here, which is called a vibrator. And so what it does, it provides a current into here, and there's a coil. That coil provides a magnetic field, and it causes a set of contacts inside here to move. When it does, it breaks another contact that causes the voltage or the current that went to the coil to drop out. So then it goes up for the magnetic current and then it drops away, and then it goes up to the magnetic current and drops away. This happens very fast. This thing sits here and vibrates. And it vibrates very fast. And as it's vibrating, it's also making contact with some other contacts down here. And as it's doing that, it's taking that center pole of that transformer and sending it to one side of the coil and then to the other side of the coil. So it sits there and goes back and forth. And while it's making contact, it goes to one voltage and then it drops out and goes to the next voltage and makes contact. So what it does is it creates an alternating current in a square wave. So then that puts an alternating square wave on the primary. And based upon the windings ratio, you got 2 secondary windings. This one will deliver 1,150 volts AC, like magic. You'll hear this thing starting to buzz, and then the voltage here will spike up to 1,000 volts. This other secondary is putting out the voltage necessary for the plates on the amplifier tube, which is 120 volts AC. Now when we send this voltage on to the photomultiplier tube, the AC needs to be turned into DC. So there's a rectifier in here, and that rectifier is here. So this 1,150 volts goes into the plate of here. It's also activated by the heater, and that's what provides a rectified current out that goes into the photomultiplier. Okay, and then how the amplifier works and so forth is about how to adjust for, how much signal comes back from the photomultiplier based upon light coming in. And I'll describe this later. But as the light comes in, you get more and more voltage back out of this, or current. And as it comes in, it operates an amplifier tube. The unit knows whether that's enough to trip it to low beams or not based upon this coil right here. And this is called the sensitive coil. They don't call it the sensitivity coil. They call it the sensitive coil. Why, I don't know, but we're going to be very careful about how we talk about it. So anyway, and then this is one of the adjustments, several of the adjustments that are used here, here. I think there's an adjustment here, and there's another adjustment here that are used to set this thing up in terms of the sensitivity. One of these is also used basically to adjust the eye for whether or not it's looking through a clear windshield or a tinted windshield. And those are the things you do to set this thing up. Now they make special test units for setting these things up that have a special light source and filtering that provide a certain amount of, I guess, lumens into here, so you know how much light it takes to adjust this to operate where it would make the most sense when you're operating in a car. I don't have one of those test boxes, so I'm not going to be calibrating any of this. I'm just going to be verifying whether or not it'll work with absolutely no light or with light coming in. We'll see what we can do with that. But I think what I want to do is, since we have very old capacitors in here that could operate like a short, okay, what we want to do is go in and open this thing up, and we're going to check to make sure the winding of the transformer is okay. I can do that by pulling this out and checking those 2 points. This is the vibrator. I can pull out the rectifier tube and get access to that plate point right there, and we can verify that we have, and also over here, we can verify we have continuity through these coils. Okay, and then what I'll probably do is put the vibrator in, turn up the voltage, and energize the primary and then measure what we get out of the secondary before these two tubes are plugged in. If these are not here, they won't conduct and the rest of the circuit won't work. So we don't have to worry about it pulling much current that way. Anyway, that's the plan. Sorry for that really long-winded operation, but just description of this. But I think this will be really, really interesting. I've looked online. I haven't seen anybody who's done any kind of review of an Autronic-Eye about how they operate. I've seen them put it in cars and turning the head, brights and lows on and off, which is great because I don't have a 6-volt battery. I won't be able to really operate headlights per se. I do have 2 6-volt headlights in case I can make it work. But chances are I won't be able to deliver enough current. We'll just see. Meanwhile, we can go ahead and see if this thing will operate. And there's some troubleshooting information in this booklet here that talk about how to test this outside of a car and without having full headlights on it. So we can verify that all the circuitry is working before we put all the full loads on it. So anyway, that's the plan for this video. I hope you find this interesting, and we're going to kick off and get going with it. So hang on, let me get the teardown of this set up. Okay, so I talked with the owner, and he's okay with that procedure that I talked about going in there and doing some testing by pulling these out, checking the coils, see how the transformer works, getting the voltage up, energizing the primary, and checking out the secondary. So that's what we're going to do. Okay, let's take a look at this up close. You can see this looks brand new. You guys have always wondered what is metallic grains look like. You can see that in galvanized coatings. You can actually see the crystals. You used to be able to see those on light posts all the time. Anyway, fuse inside, guide, Autronic-Eye. Look at the chromate. It's like it's mint. Chromate is a type of a dip that's used to passivate the surface to prevent corrosion. You'd see this on carburetors and things. If this was straight aluminum, you just dip it in chromic acid, but if this is steel, which I believe it is, yep, then you had to do another dip first as well. Anyway, so it's got grommets that look like they're isolating the case from the ground of the vehicle. This is called the hold adjustment. I'll need to see which one that is. Okay, so to open this case up, let's look at the cabling. Okay, so one of these goes to the wiring harness that comes from the, I mentioned from the battery earlier. Actually what it is when you pull on the headlights, that provides power to this. So here are the 2 cables. So one of these would come from the headlights switch and then go to the high and low beam, and then the other one goes to the eye and the foot switches. We'll look at that a little bit later, but you can see what all we got here. Okay. All right. All right, to open this up, we've got 4 screws in the corners. Let's get to opening this thing up. Is it true that this hasn't been opened in 70 years? I don't see any indication so far that it's been opened, but we'll see. So here we go, we're going to open this thing up. Wow. Warning, high voltage. No kidding, right? By the way, I was noticing how shiny this piece is. All right, we're going to take a look at this. Well, this is obviously the vibrator. Now I know they make solid state vibrators, and I've used one in the Chevy radio that I did, but you have to be careful. You got to make sure you get one that's a 4-volt, and I'm not sure if I can just substitute that same type of vibrator in this location. So I'm going to do some research on that, but otherwise I'm going to leave the vibrator in here. Alright, so there's a big adjustment rheostat. Here's a relay. I'm assuming that's the quote sensitive relay. There's our transformer in there. A couple of our caps. We've got tubes here that are guide tubes. So if they're bad, I don't know what we're going to replace them with. So that says guide. That one says guide. Let's see, one of them's a ballast, the other one's a rectifier, and the other one's the amplifier tube. The amplifier tube looks like it's got a lot of pins on it. Yeah, it's got the same. Okay. What is this? 150. That's a 15 ohm. I'm reading that right? Oh, I see it. It's here. Right. Item 10, 15 ohms. Got a lot of wattage. Got another adjustment here. Here's the fuse. It's supposed to be 14 amps. Okay, well, one of the first questions is, do we think anybody's been in here? I don't think so. Somebody may have looked in here. We'll never know about that. But I don't see any calling cards they left as in any kind of changes or anything they've done. I'm looking at the tubes. This is the ballast tube. You can see there's a filament in there. It's just a filament. You can see in there. So I'm pretty sure that's the ballast. And one of them's a rectifier. I'm assuming it's this one, because we've got a lead coming from the transformer. Let's take a look at these capacitors. Okay, so that might be a capacitor here. .00025. That's right here. So that's a smoothing capacitor, and that looks like a wax and paper. So I was hoping that was going to be mica, but we may need to change that one. But look at that perfect old resistor. Has not ever been overheated because it's never been used. I know I'm gawking at this too long, but how often do you see something that's this pristine, right? 70 years old, guys. So here's the relay. That's this relay right here. Yep, contacts work. Can you see them? Awesome. I'm going to look at this for a while. This is the visual inspection part. You look at it and see if there's anything that looks weird or bad or something. Okay, so how many caps do we have in here? So we have one here, 1, 2, 3, 4 down there, 5. I see 5 caps, and they look like they're all probably need to be replaced. Let's see how many I count here. 1, 2, 3, 4, 5, 6. So I'm missing some somewhere. I'll find it. I'm going to finish doing some visual inspection on this, and then I'll bring you back when I'm ready to start doing some of the testing on the coils and so forth, see what we got. So let me take some time. I want to make sure I give it a good opportunity to find if something's wrong. I can spot it now, and then when I bring you back, we'll be ready to move on with what we're doing. Okay, so let's take a look at some of these measurements. So what I'm going to do is, I think what I'll do is, in order to check this, I'm going to go ahead and pull the vibrator out, and I'm going to pull the rectifier tube out, and I'm going to pull the amplifier tube out. I guess I could go ahead and pull the ballast too, but that's just to verify that the tap is communicating. Otherwise, I can just go end to end on the coil. But if I do that, I can probably check it other places. So I'll pull it. Okay, so here is the ballast tube coming out. Very nice. So the tube designation is looks like a Chevrolet part number 59444545. You can see the rectifier, the filament resistor in there. Let's get a little bit of dust on here. We need to be careful because that looks like paint and it might rub off. Alright, so that is that tube. This one, I believe, is the amplifier tube. Yeah, you can see the paint's trying to come off on this one. And it looks like a 3333 or something like that. So that's the amplifier tube. This one's got the yellow dot on the top. This is the rectifier. I believe. And this one's also got a Chevy number 5943334. And then of course this is the vibrator here. It's got a lip on it. Probably going to skin my knuckles. Come on. All right. Five nine four 3336. Look how clean that is. Don't you wish you could just buy new old stock stuff all the time? I mean, look at those. Look where those pins go. The tube sockets. Okay, let's start doing some measurements here. Okay, so to go from one end of the primary to the other end of the primary, I want to go between the two small pins of the vibrator. So two small pins, looks like it's this one and this one. .03 ohms. Now you might be thinking, gee, that might not be, might be a short. Well, look what our turns ratio is. I mean, we're going to go from 4 volts to 1150 volts, so you'd expect quite a bit of difference there. I'm not going to call that a short. This would be a short. So that's a short right there. Okay, so the primary looks good. I can go from one of them to pin 4 of the ballast tube. These are not really, let's see, 1, 2, 3, 4. Yeah, that's it. And that's to the center tap. So that's the center tap to one of the legs. So that's from here out. So I think that's okay. And then let's see, to check the secondaries now. And what I may do in a minute is I may try to see if I can see that coil with a component tester. Okay, let's check here. We can check this one right here by checking between the plate and the other leg of the ballast. So I said this is the ballast. Here it'd be this location here, I believe. 5K. There's K ohms down here, see? So I think the small secondary looks good. Now let's try the big wire, the big one. Okay, I think that is it. And so it's there on that big capacitor, which is right here. And the other one I'm going to pick off the plate of the rectifier tube socket, which I believe is here. And 3.4 kiloohms. 3.4 kiloohms. Was that other one had a higher resistance? Shouldn't have. This one should be the highest resistance, right? So that's 4 kiloohms. And the other one, oh wait a minute, I'm going through the choke. I'm going through the coil going that way. Yeah, I was measuring going through this coil. I don't want to do that. I want to try to pick it up over here. So let's see, I want to be on the positive lead of that electrolytic, which is here. And then the other lead I can pick up off the ballast tube. I think I said here. Yeah, that's much better. This is 213 ohms. The other one was in the thousands of ohms, and then yeah, that's more like what I was expecting to see. Okay, those coils all look good. For grins, I want to see about checking a few of these on the component tester and see what I get there. So hang on a minute. Let me get that set up. We said we pick these up off the small pins of the vibrator. So there's one. There's 2. Let's see what we got. And there's that winding. Yeah. 0.6 ohms, it says, and 0.01 microhenries. So there's that coil. So the coil is there. If we were concerned about there being low ohms, it's there. I could check the other ones, but I'm not going to do it right now. Let's move on along here. Okay, so we said we're going to do next is, since we verified it looks like the windings are there, okay, what I thought I'd do is go ahead and put the ballast tube in, put the rectifier tube in, and then rig up to put some voltage in, put in some 6 volts, and then be ready to measure the voltage coming out of here. I'm going to leave out the rectifier tube and the amplifier tube So there's no conduction coming off of these, so there's no current flowing. And let me get that set up, and then I'll bring you back when I get that set up. Okay, I'm all set up to measure the voltage on this and do some testing. But I've spent a lot of time looking at what I'm seeing here, and I got getting ready to hook up the power supply connections to this, and I'm getting kind of confused with the way some of these things are wired in here. So I think what I'm going to do is take a long break and think about this. So let me just show you what I'm talking about. So what I like to do is hook up the positive lead coming in to one side of the fuse, right? The side of the fuse that's away from the circuitry of the amplifier. Okay, that's the fuse. And then hook up the ground to just one of these ground parts on the chassis. All right, so which end of this fuse is away from the components of the amplifier? Well, let's see. So here's the fuse, right? Let me zoom you in here. So as I look at the fuse, find something to point with here. This side of the fuse here, I don't have any power hooked up to this. This side of the fuse here is connected to this chain of 1 megohm resistors that then connect up to the power control. So that here are those two resistors and the power controls on the other side. So here they are, and they come down and they jump over and connect, jump over, come down, and connect to the top side of the fuse. That makes sense. And then it's supposed to continue on over here, connect up to here, and then connect up to the, I guess you'd say, the high side of this filter capacitor. Well, filter capacitor 9 is this one right here on top, right here. And I can see, well, here's the ground side of 9, and there is the chassis ground. There's a place right here where it ties to ground. Okay? But this should be wired here. Alright? Because this and this are on the same side of that fuse. Oops. It's on the same side of that fuse. There is the top side of 9 and then the ground. There's the top side of the fuse. And then this comes over here and connects up with that chain of 1 meg resistors. So it looks like this fuse is actually between here and here, but not between here and the incoming line. So I need to find out what's going on here. At first I was looking at this cable right here, and I thought, well, maybe this is in the wrong place, because that's not a really particularly nice looking solder jobs, the way the wire's frayed out here, and I thought, well, maybe somebody's messed with this. But it still didn't explain why these are connected here. So then what I did is went into the manual, and in the manual there's a drawing that shows what we should be looking at here. There's not a photograph like Sam's would have, but it's got it has a drawing. Let me find it. Right. So here's the part of the drawing that shows where the fuse is. And here it shows that line coming up and going to this left side lead that has the resistors going to it. Well, that's exactly what we have here. We've got this lead coming up, and we've got those two resistors tying to it. Then over here we got this lead going to the capacitor and these two red leads. Well, here is the lead coming from the capacitor, and there's the two red leads. So I'm going to need to think about this before I put power to this, to make sure I understand what it's doing. I've got another drawing I can look at. I'm going to take some time to make sure I'm looking at this right, because that's kind of confusing. Let's be careful, right? So I'll probably come back and look at this in tonight, and then pick this back up in the morning after I'm rested. Make sure I'm very certain about what I'm doing. All right, I'll bring you back then. Okay, so it's the next day. I've been giving this a lot of thought and doing some research online, and also chatting with the owner on this. And we pretty much agree that, yeah, I mean, this fuse is shown along this line and actually kind of between where this here ties in with this circuit. So this part here is, if you will, on the left side of the fuse. That's on the left side of the fuse, meaning left side of the top here. That's also on the left side of the fuse. It's just that the power line and this part right here are connected together on the south side of the bottom side of this fuse, and that's just not the way it should be. And I found another schematic online of this. I think actually dates after the schematic, and I'll pop it up here on the screen. It shows certain circuits in different colors, which is kind of nice. And also, if you look in the lower right hand corner of that schematic, it'll indicate that there is a resistor and a capacitor that had been eliminated from later versions of this circuit. They didn't say why. But basically the fuse is shown on the right hand side, and it basically agrees with the same thing this one has. So let me get that out of the way. And so basically this is still holds true. The capacitor, it said, was eliminated, was this one, which explains why I wasn't able to count up the number of capacitors before. This one's no longer there. And it said also that this resistor, this 5.6 meg resistor, is eliminated. Well, this unit does still have this resistor, so it's kind of in between, I guess. Any rate, so I think for what we're doing now for testing the output voltage of the secondary, since we pulled these two tubes, we shouldn't be getting really any current flow. I'm a little bit worried about this capacitor leaking, and I know it is leaky, but I've got current limiting here. I'm not going to be able to put out enough current, I think, to cause any damage. But before we go to full power, I think that we ought to consider switching this back and maybe changing this cap out. We'll just see. But, you know, I could see, you know, maybe did somebody just decide, you know, hey man, it'd be a lot easier when we're making this if we can hook this up here instead of here. You know, someone would say, you know, well, that's not the way the schematic looks, but if you do the math on it, you can say, well, okay, so if you had a short here, let's assume that this right here was all the way adjusted to 0, okay? So you had 2 megs. The first thing that 6 volts would see is 2 megs. And if you had 6 volts into 2 megs, I mean, you're into microamps, and it wouldn't blow the amp anyway, blow the fuse anyway. So I could see somebody saying, what's the difference? But still, I mean, that's just not the right practice. So I think before we get to full power on this, I think what I'm going to do is wire this such that the resistors here go to the amplifier side of the fuse as it's shown in this schematic, because that's just good practice. It won't hurt anything. It's interesting that when they did the drawing, you know, the realistic drawing of this, they drew it just like this, but that drawing did not agree with the schematic, this one or the later one. So anyway, what I'm going to do is we're going to go ahead and do a test of the voltage we develop in the secondaries here. Like I said, we've got the rectifier tube and the amplifier tube pulled, so we won't be able to pull any current apart from maybe anything that might be shorting, such as maybe that. I'm going to have it on current limiting and so forth. So let me, I know there may be some people new to my channel on this, so just a quick description of what we got here. So what you see here is the power supply. This is regulated, so I can kind of control the voltage, and it'll hold that voltage regardless of the currents going. But there's a couple of things to know about this setup. So the power supply is not connected directly to my house current. It goes through what's called an isolation transformer. So if I come across touch one item somewhere in here, then I'm not completing a circuit unless I'm touching something elsewhere. So that gives some degree of safety to me. It also means if I hook up some other piece of test equipment like an oscilloscope, that I couldn't accidentally come across line voltage into, like, say, the ground circuit of my oscilloscope and blow it up. So that's one of the things the isolation transformer does. But the other thing that's probably a little bit more important is that I have on the output of this current limiting beside the fact that I can see what the amp says here. So the current coming through here is actually going first through a light bulb that's in series. So the light bulb is actually back here. It's a 6-volt seal beam headlight bulb. And what that does is that makes all of the current that goes through here go through the light bulb first. So if you were to imagine if this went straight dead short, all that would happen is that light bulb would go full intensity, and it would not allow this to go to its full amperage capacity. That light bulb would take up most of the power that comes in here, and that limits the current here until I can correct what's going on. When I'm working on things like high voltages and radios and things, this has allowed me to work on items that have shorts on them, that actively have a short that still work, and I can find the error while it's in that condition without causing any damage. Anyway, it's just a typical thing you see on tech benches. All right, so I just said that because some of you guys come in here for an Autronic-Eye might not know anything about the radio stuffs. So I have a current limited, regulated, isolated power system on here, which would normally y'all wouldn't have. Okay, anyway, so I think we're ready to get started with this. Let me get the meters hooked up, and then I'll bring you back. Okay, I've got the meters hooked up, and I've got them wired in. So what I've done is I've got the power coming from the power supply after it goes through the light bulb, which we call a dim bulb, then comes up, and I've got it tied in. I've got the negative tied up to a ground location. There's a nice ground location where this is right here, which is right there. And then the positive I've hooked up to where this lead here is connected at the end of where these two 1 megs are, so that amounts to basically that side. So I've got it right here, and so we don't have any fuse protection really, but we're under current limiting, and we're not going to be pulling really much power, so we should be okay since these two tubes are not there. Okay, now in terms of order to measure whether I'm getting 1150 volts out of this secondary right here, my meter here is rated for 1000 volts. Okay, so I have to take steps to be able to measure that much voltage. So Fluke makes a high voltage probe that goes with this, and this one is good for 6000 volts. And what you do is just plug it into the meter here. It's got some dropping resistors and a shunt inside of here to allow you to plug it in to this meter. And then what it does is this makes the meter read 1 volt on here is equal to 1000 volts here. And I can verify that by, like over here on my panel, I've got 120 volts roughly coming in. I can just verify that by, I'll hook this up across that. So we should be looking at about 120 volts here. So it should say roughly 0.12. Okay, here comes. There you go. So 121 volts reads as 0.12. So like I say, 1 volt on here would be 1000 volts in reality. Okay. So what I'm going to do is I'm going to hook this lead. I want to measure first the voltage coming out of that high voltage side of this transformer right here. So what I've done is I've connected the ground lead, if you will, on the high side of that capacitor. Okay, and then what I'm going to do is touch the other side of the lead to the pin socket for the plate of the rectifier. Now the rectifier is not in there, but I know where this wire is, and that wire is right in here. So I'll be touching that with this probe, and we'll be able to read this out. And we're looking for nominally 1 point and then maybe 2 or something, because we won't have any load on this. So I expect it to be a little bit higher than 1150, right? Okay, if you can see everything here, I think we're ready to go. Let me do another real quick check. It's important that I put these here so that any voltage drop that I might have in the leads is removed by sampling it directly as it goes into the unit here. Okay, so we're ready to power this up. And I'm going to put this on that plate. I'll do that now. Now what we hope to see is I'm going to bring the voltage up, and you may hear the vibrator kick on. Okay, so power up, swap hands, voltage up, bringing up the voltage now. Trying to get it where you can see. Well, this is the actual voltage that's being applied in DC. I see my error. This is to be in DC. Right. So this is in DC. This should be in AC because I'm going to be looking at AC voltage coming out. Okay, so for example, I got 0.22 amps being pulled. I'm at 2.9 volts out of this unit, but the amplifier is only seeing 1.5 due to losses in the bulb, the light bulb, and the cables. All right, so let's bring that up. We're looking at this. Listen for the vibrator to kick on. And then when you hear the vibrator kick on, watch this. Okay, moving half an amp. That vibrator should be working by now. Okay, we've got a problem somewhere. I want to go through and check some resistances and so forth. That should have operated the item. So we'll see what we find. Try this again with a different meter, just because. Okay, turn the voltage down, bring it up. I'm getting better reading now. Not sure about that new yellow meter of mine. Okay, it says I should be getting 2 volts through. Let's see if we can hear the vibrator kick on. It should have been running by now. Okay, I'm wondering if maybe I'm going to check some voltages. I wonder if maybe the ballast tube is no good. Let me see if the voltage is getting to the, I'm going to bring the voltage down low. Let's go about 2.5 volts. That's not enough to kick on the vibrator. And what I want to do is I want to check to see if the voltage is getting through where it's supposed to go. Bear with me a minute. Go to DC, right? Am I getting voltage on this side of fuse? Yes. Okay. So there is the ballast. The ballast tube. Okay, I should be able to pick up positive voltage there on top of 9, right? And then this should go here. That looks good. And now what I'm going to do is go to the other side of the ballast tube, which is where? Here. Looks good. So I've got continuity through the ballast. That's going to, there's that big resistor, that's here. So I should have that going into the primary. Okay, let's check to see if there's anything coming out to the small pins of the vibrator. There's one there. Yes. And the other one is here. Okay, I'm getting voltage to both sides of the vibrator. Right? Oops, I'm looking in the wrong place. Here, yes, and here, yes. So I'm getting DC to both sides of the vibrator. So the vibrator should be getting enough to operate. There's the center tap. And it's going both sides like it should. Then here's the ground, should be nothing, right? So I've got voltage going to the vibrator. The vibrator's not running. Vibrator is not running. Conduction to the pin is there. conduction to the pin is there, and that is 0. Looks like we got a problem with the vibrator. Looks like the vibrator is not running. Okay, I'm going to up the voltage on the vibrator, see if it'll kick in. Here we go. The vibrator should be running by now. It should start at around 4 volts at least. Still pulling a 1/2 amp. Not real happy about that. Am I getting... So it should be 5 1/4. Well, this is after the ballast tube, so that makes sense. See, because this is what's going to the ballast right here. That agrees. This is what's through the ballast. Dropped it some. Then actually that should be lower, right? The ballast tube should be, well, I'm not drawing any power. Any voltage is the problem. Any current is the problem. If I go here, yeah, I'm getting voltage to the small pins. 5 volts. 5 volts. The vibrator is not running. Shall we try something scientific? I think the vibrator's failed. It's got the right voltages going to it, but it's not operating. Okay, so I think we can either try to see if we can... Let me take a look at it and we'll see what we want to do. Okay guys, I'm going to cut this episode off here. We've done quite a bit in this first part. We've gone through and checked to make sure the transformer wirings are there and look good. We've checked a few other things. We verified that we've got power getting through to the vibrator, but the vibrator is not running, and so this vibrator has simply failed. So in part 2, we're going to take a look to see if we can figure out how to get this vibrator to work. So until then, thanks guys. I appreciate you watching. Take care. See you soon. Bye.